Our final biochemistry project is on clean drinking water.
So for our mainstream article, we chose to use a video by Mark Rober titled Drinking Nasty Swamp Water to Save the World. And it demonstrates the use of P&G purifier as a way to produce clean drinking water. The main idea of the video was to highlight a product that has the ability to improve the lives of people in less developed countries that don't have access to clean drinking water. Procter & Gamble purifier powder only costs pennies to make, which they also sell at a loss to improve the lives of people all around the world. The findings of the video are the 3 steps of the powder explained by its creator, Philip Sauter, who's a laundry scientist at Procter & Gamble. The first is coagulation, where positive seed crystals attract negatively charged dirt. The next is flocculation, where flocculants grab the bacteria chunks and their density increases slightly to where they sink to the bottom. Lastly, the chlorine kills 99.9% of bacteria, resulting in clean water at the top. Later in the video, Mark Rober brings in Bill Gates to explain 3 impacts that aid will have on less developed countries. Firstly, it will foster education and new economic ties that are beneficial for both countries. Second reason is for our own safety. Financial aid offers stability, which discourages radical ideology. And Bill also predicted that the next pandemic would spread fast from the poor countries into the rich countries. And so better healthcare systems in poor countries would be very important. The final point was for our own prosperity. We want other nations to create products for us to trade with, and this improves both our lives and our economic systems.
In our research article titled Innovations in Nanotechnology for Water Treatment, the authors discuss 3 types of nanotechnologies which show great promise for use in water purification. The first one, nanoabsorbents, include materials such as carbon nanotubes, metal-based absorbents, polyameric adsorbents, and zeolites. As the name suggests, these materials use absorption, which is the process of which molecules of gases and solutions stick to the surface of an object via electrostatic attraction and bonding, which you can see in the bottom image. The authors note that these materials are promising because they are very efficient and could be regenerated via pH shift, but these nanoabsorbents tend to be complex and expensive to make. The second technology that the authors discuss is nanometals and nanometal oxides. These metals, like nanosilver, nanotitanium dioxide, and magnetite Fe3O4, also work through absorption. However, some metals like the nanotitanium dioxide are photocatalytic, meaning that when hit with ultraviolet light, with a wavelength between 200 to 400 nanometers, they can cause a chain of redox reactions that are efficient in degrading organic material. Despite this, one downside of nanometals is that they are not as reusable as the nanoabsorbents. And the last technology that the authors discuss are nanomembranes, which act by providing a physical barrier for substances to pass through based on particle size and properties. Of the 3 technologies, these membranes are the most diverse, boasting high specificity. However, they require high initial energy input. Overall, these authors see high potential in each of these 3 nanotechnologies. However, more research should be done in making these materials more efficient, safe, and available for everybody.
When comparing Mark Rober's video with the research article, the video was easier to comprehend, and the information presented in a visual format was easier to process and retain. Mark Rober's video on P&G water purifying packets was more engaging and likable, as the experiment was demonstrated in real time, illustrating the coagulation, flocculation, and disinfection of the water. In the video, visual diagrams and animations were used to simplify the mechanism behind the packets, showing the particles in the water and how they are separated to create clean drinking water. The interview with Philip Sauter, the laundry scientist behind the creation of the packets, was also highly insightful, as well as the interview with Bill Gates in discussing the motivation to help countries in need. In regard to the video, while Philip Sauter, being the creator of the P&G packets, is certainly qualified to discuss its use and implementation, there may be a slight bias as he is part of the company that distributes it and would most likely not talk badly about the product. Despite this, it was stated that P&G sells the packets at a loss, meaning this is somewhat unlikely. Bill Gates is also a highly credible individual, but his expertise is not in the process of obtaining and distributing clean drinking water. Mark Rober's video was thorough, but it could have included some drawbacks or obstacles for the implementation of the packets throughout developing nations to make the video more well-balanced. While the chlorine in the packets were stated to eliminate 99.9% of viruses and bacteria in the water, a further look into the health impacts of the water packets could have been useful. There was also little mention of the specific implementation of the packets, such as where and how they're distributed. For instance, what kind of bottles are used for the process. It would also be good to know if the water packet process is streamlined with many bottles at once, or if the packets are used on an individual level. Furthermore, a discussion of a specific country that has access to these packets and its effects would have been more insightful.
While both the video and the research article are presented well backed with credible resources, the innovations in the nanotechnology for water treatment is way more trustworthy, as there is 100 references for academic journals and case studies. And because of this, we can understand the fact that it's less likely to have bias and is more well-rounded. And this shows the credibility of scientific articles such as the PubMed and Science Direct, and those type of journals are really helpful for establishing information about medical and science information. Some drawbacks from the research article include that it is longer and way more sophisticated, and with that is more sophisticated language. This article focused on heavily important mechanisms such as nanotechnology and obtaining clean water. And because of this, they didn't really go into many real world applications of nanotechnologies, and that showed like a drawback of how the article was shown. In addition, the article did not have much information and implementation of a discussion within developing countries. And the developing countries are the ones that are a main focus point for establishing the problem of water scarcity in our world. Finally, the research article specifically, did not really discuss the costs and potential outreach for these nanotechnology processes. Finally, I'll go into the significance of water purification today. So a neat or kind of sad data point is the lack of clean water is responsible for more deaths in the world than war. And personally for me, I come from a high developing nation and country of Nigeria, and things such as water scarcity is an important problem for that country and many countries in Africa and many third world countries. In addition, the whole world has increasing global populations, and water scarcity is a real big problem towards that. Finally, things such as climate change is really going to affect our world, and we need to find the problems and ways to combat that. And having processes such as water treatment and the ones that we've discussed in our projects will really help and emphasize the fact that clean water saves lives. Finally, we have we're excited for the sources that we use for our project, and thank you.